boys and girls, ladies and gentlemen, bugs and basket weavers of all ages. Welcome to your first physics lesson. We're actually not going to dive straight into physics. And the reason for that is you guys, as good as your math teachers are at teaching you math, there's a bunch of stuff they don't teach you that's very imperative for your understanding of the physical world around you. So we got to do some cleanup and some formalization of a couple of concepts before we get to how blocks do stuff and, you know, how the universe be. So we're going to do a short prerequisite unit to just get you kind of up to speed, make sure you understand all the words that are coming out of my mouth, and then we will talk about how blocks be. So what we're going to talk about today are units. These are things that you have definitely seen floating around all over the universe, but I don't know that anyone's ever sat you down and be like, listen, son, this is how units are. So we're going to just take some time, talk about units, talk about which units we're all going to use to make our lives easier. And then, teeny tiny little bit of math. So we're going to talk about how to understand units today. But first, a short cartoon. Typically when I show kids units, there's this really slick video that I show of this kid that just won a bike race or something to that effect. But I don't think I can show you other people's videos in my YouTube videos, right? Unless I do a reaction video, in which case that's fair game, right? So anyway, this kid here, he just raced a bike. And this guy, we'll call him Larry. He says, "Congrats on the win today. How fast were you riding?" This kid says, 12. You can already tell that sounds weird, right? 12 what, dog? 12 hippos? I don't know, 12 speed? 12 speed, right? So we need units to understand what this 12 is measuring, right? Units are how we label the measurements that we take about the real world around us. So it's important that we understand how those things work. Otherwise, you're going to sound kind of weird, right? How fast were you going? 12. So let's talk about some units. So one of the first things you need to know is that there is a standard system of units. We call them SI units. And if you've taken chemistry, you've probably heard this phrase before. SI is not an abbreviation. What's the word for things, just letters that represent words? Acronym, maybe? SI units is short for Système International. This word is French. So you're going to have to ask your French teacher how to say this like a French person. But I'm going to say système, right? So SI units are just the international system of units. So everyone around the whole world has agreed these are the tightest units that exist. So we're going to all use these units to make our life as tight as it can possibly be, right? These are the raddest units, and we want to use them because it makes it easy for people to work together. It makes them easy for them to compare results, and it creates standards that when you are engineering something that we can all nicely agree upon, right? If I say, how much weight does this shock for your car need to hold? And you tell me 12,000 stones, right? We're not like 12th century Vikings, right? I have no idea how much a stone weighs. Please give me a unit that everyone knows about, So SI units are the international system of units that everyone in science has agreed to use because we need something in common so that we can talk to each other, basically. Please tell me. Yes, I did. All right. So let's talk about this cool little color wheel thing. So when you measure stuff in real life, every physical object or interaction in the universe we can measure, we hope, right? If there's unmeasurable stuff, well, we can't measure it, so who cares, right? But everything that we can measure is made up of basic building blocks of units. So because there are so many different interactions, there are tons of different units, right? But all of these different units are built up of the same smaller units. And we'll kind of dive into this a little bit more later. It's kind of difficult to tell you any concrete examples because I would say one and you'd be like, I don't even know what that thing is yet. So we'll get there a little later, but I've got an example a little later on. So for this class, there are only 3 units that we are really going to build bigger, better units out of. And those 3 units are these ones right here. We just want this little chunk of like orangey red section. So we are going to use for mass, we're going to use the kilogram. This is a metric unit, right? You're going to say, why don't we use pounds? Technically, pounds isn't even mass. Wait, hang on. I apologize. I can't talk and write at the same time. So for mass, which is a measure of like how much stuff is there, how many atoms are there, not how many, but how much atoms are there. We're going to measure that in kilograms. For distance or lengths, we're going to use the meter. And if you are from anywhere but the United States, you probably already use the meter. Sometimes I have students who went to school in Mexico for a little while, and then they come here and they're like, oh yeah, it makes more sense to me when you tell me numbers in meters and centimeters than when you tell me them in inches and feet, because this is what I'm used to. Because I think if you look at a map of the world, there's like the United States and one country in South Africa that doesn't use the metric system. Everyone else does. So we're going to just use the metric system because it's better in every way. So when we measure distances, lengths, things of that nature, we're going to use meters. The last thing that we are going to be measuring in this class is time. And there's no metric version of time. It's just seconds. Of course, we're going to get answers like how long does it take the Earth to go around the sun? You could calculate that in seconds, but you're going to get a huge number. So these are the standard units we're going to use. These are the units we're going to build other units out of. But that doesn't mean we're not going to take pit stops and be like, okay, well, it says 3,600 seconds. Let's just call that 1 hour. Right, we'll go back and look at them in like units that we know a little bit better, just to give you guys a visceral understanding of what these things are. But, you know, you'll get there. All right, so let's talk about what do I mean when I say that these are building blocks and we can make other units out of them. So let's take, for example, speed. We want to talk about what do I measure speed in? And you know, but it might not have ever crossed your mind like what you're saying. It's one of those things where you just say it because that's what it's called and you don't think about the words coming out of your mouth, right? So if we look at a speedometer, this guy is going, 55 miles per hour. Okay. So our 3 building blocks is meters for lengths, seconds for time, and kilograms for mass. This is if we're using SI units. Let's maybe turn these into some things that are a little more familiar to us, just so we can look at this problem a little easier. Maybe instead of measuring lengths in meters, let's use the American version. We'll turn them into miles. We'll talk about miles for right now. And instead of measuring things in seconds, because it doesn't take you 3 seconds to go to the store, it takes you a couple of minutes. If you're going really far, it takes you hours. So instead of measuring time in seconds, we'll measure it in hours. So if we look at speed, we don't say, I'm going 55 speed, right? This is not what comes out of your mouth when your mom asks you if you're following the speed limit. You say, no, Mom, I was on the freeway. I would only ever go 55 miles per hour. That's what the speed limit is. What many people don't realize when they say this is that they are saying a number of miles or a distance per a unit of time. Miles per hour is a unit that is a distance unit divided by, that's what the word per means, a time unit. So we don't have a new unit. We have a unit made up of two of our building block units, or units that describe the three kind of fundamental things you can measure about stuff. So eventually we will get things that are too complex, right? We'll get things that are like kilograms, meters per second squared. And then instead of saying kilograms, meters per second squared every single time, we'll give this a new name. We'll call it a Newton. But a Newton can still be broken down into our three fundamental building blocks. Okay? So I will take a lot of time when we learn new concepts to go over what are the units of the thing we're talking about, and then tell you any, abbreviations or new units and explain how they're broken down. And we'll look at equations. It'll be a really great time. But just realize there's really only three units we're going to deal with, and we're just going to mush them together in different ways to make new stuff. Okay. The last thing we need to talk about is the metric system and how the prefixes for this system work. In a later lesson, we're going to talk about how do I convert between, say, kilometers and centimeters. But today I just want to kind of give you an overview so that you kind of get your teeth into it and aren't worried too much about being beaten to death by a math problem. So for the metric system, there's like a saying. It's kind of how trig functions, SOHCAHTOA, have like a phrase to help you remember it. So is the metric system. So it's called a mnemonic. And it goes, King Henry died drinking chocolate milk. If you're really creative, you can come up with something else that has KHDDCM. Enjoy. This just helps us remember the order of the prefixes. So king goes with K for kilo. Kilo is telling you there are 1,000 of whatever the base unit is in that thing. So if we were talking about 1 kilometer, what that's saying is there are 1,000 meters in one of these. So kilo basically means 1,000. Hecto means 100. Deca, and not like the club deca. Deca means 10. And then we just have our base unit. So whether it's meters, grams, liters, whatever, those are just the base unit. And then we have smaller ones. So you can think about them as being decimals, but I find that kids really often are scared of decimals and fractions, right? You're like, I have 3 fears in life: disappointing my parents, swimming, and fractions. So it might be helpful to think about how many of these small ones are in the base unit. So once we go past the base unit, we get to deci, not to be confused with deca. Deci, anything with C in it is usually deci, centi, milli. Anything that has an E is small. So decimeter is 1/10 of a meter, or 10% of it. So there are 10 decimeters in a meter. Centi means you're cutting it up into 100 pieces. So in 1 meter, there are 100 centimeters. This is one that most people use instead of inches in civilized countries. And then milli is 1,000ths. So in a meter, there are 1,000 millimeters. Okay, so we are pretty much going to only be really using kilo, centi, and milli. Those are the ones that show up the most often. if you're buying land, sometimes they will show you hectaacres. That's really the only place I've ever seen hecto used. Deca, most people just say 10, right? I don't know. These ones in the middle here are not really used as often, but otherwise the acronym doesn't work if we don't teach them to you. So kilo is 1,000 meters. Hecto is 100. Deca is 10. Then we have the base unit. Then the smaller ones. Deci is 1/10 of a meter. Centi is 1/100th of a meter. And then milli is 1/1000th. There are bigger and smaller ones, and I think you'll get a reference sheet. It's probably shared with you in Canvas already, but I believe they show you some of the other ones. But you might want to keep this chart handy. You don't necessarily need all of this stuff written down. What I would write down are these and these. All right. So hopefully that kind of gives you an understanding of where units come from, what we're going to be doing with them, kind of how the metric system is organized, and then you're going to have a couple of problems to putz around with and just make sure that you kind of understood everything. So go ahead and rejoin the WebEx. If you need any help with this, or you have questions, or you feel like I rambled too much, not that I would ever ramble, go ahead and let me know. And have a great day, ladies and gentlemen. I'll see you next time.